Let's dive into a huge question. What makes something last, while other things just fall apart? From stars to societies, nothing's guaranteed to stick around. So how do systems actually survive over time?
Well, a field called coherence science has an answer. It starts with measuring a system's integrity, called coherence. But just knowing its integrity right now isn't enough. That's just a snapshot, not the whole movie.
The real question is about change. How does a system's coherence shift from one moment to the next? And this is the answer, the Coherence Flow Equation. It models that exact change in coherence over time.
It basically breaks down into three core parts: a gain term, a decay term, and a shock term.
Okay, let's look at the gain. This is all about a system's connection to the outside world. What's really interesting is that this critical openness actually depends on the system's specific architecture. Next is decay, entropy. It's just the natural tendency for things to break down over time. And finally, the shock term. This models those big sudden hits that come from the outside. But for this equation to work, we have to measure its components with incredible precision. This is a perfect example of the scientific process. The definition of noise went from a guess to a universal law. This refinement happened all over the framework, making the science way more consistent, scalable, and actually measurable. So what's the ultimate payoff here? What does this dynamic model really tell us about a system's fate? Well, it reveals three different outcomes. It all depends on where a system's openness is relative to a critical point. Simply put, closed systems are gonna collapse, but open systems, they can achieve stability and even grow. So survival isn't about what a system is, it's about what it does to manage coherence over time. This leads to a wild idea that meaning is just accumulated coherence, a physical, measurable thing. Think about that.